Okay, so we'll do trigonometry. In trig, there are actually 6 trig functions. In geometry, we cover 3. Okay, so this is kind of a little bit of background before you go on. You will get this if you go into trig. Trig actually comes from 2 Greek words. Okay, they are Greek. One is trigon, and that stands for triangle. Okay, and the other one is metron, and that one stands for measure. So trigonometry, okay, is the study it's the study of triangular measurements. Okay. And what we're going to do right now is we're going to work on right triangle trigonometry. We're still going to use the right triangle trig. We've gone through the special cases for 30, 60, 90, 45, 45, 90. But not all triangles fit into those special cases, so we're going to vary the size of these two angles. Okay, we're still going to use like ABC, uppercase letters. Okay, for the angles, and remember the right angle is your uppercase C. The side opposite angle A, the side that's opposite angle A, this side would be lowercase a. Remember the side that's opposite angle B, this would be lowercase side b, and the hypotenuse is always the lowercase c. Okay? And we're going to look at the trig ratios for right triangles. Trig ratios for right triangles. We're going to do the first 3. Okay, you'll get the other 3 when you get into trig. Okay, the first one is it's sine. Now it looks like this, S-I-N-E, but we abbreviate it to S-I-N. Okay, it's not sin, it's sine. Okay, it's sine of, and they will give you an angle. Okay, like sine of angle A, it would be the opposite side, and we're going to abbreviate opposite to OPP. Don't use O, use OPP for opposite over the hypotenuse. And we're going to use HYP for the hypotenuse. I'm not going to make you write it all out. Okay, and cosine of angle A is the adjacent side. Okay, so, and we're going to use ADJ for the adjacent side over the hypotenuse. Okay, and the last one, last trig function we're going to look at is tangent. Okay, so, and it's like cosine looks like this, cosine, but we're abbreviating it. And tangent looks like this, but we're abbreviating it to TAN. Tangent is the opposite over the adjacent. Okay, opposite over the adjacent. Probably, yep. And I always tell my students the easy mnemonic to remember this. Okay, if you look up here for a minute. Okay, some old hags can't always hide their old age. And that helps you remember it. Okay, don't think of me when you're saying it. Okay, some old hags can't always hide their old age. Okay, so if that helps you remember it, some old hags can't always hide their old age. Paul Wark, the AFS student from Australia, gave us that one a long time ago. Okay, okay, now I'm going to go through an example, some examples. Okay, say I give you a triangle, and on these it's always helpful if you draw the picture. And these will all be right triangles. And this one I'm going to give you N, label this as L, label this as N. They don't have to use ABC on every one of them. Okay, and the author will say, find sine of angle L, cosine of L, tangent of L as a fraction and a decimal to 4 places. Okay, now here's what I want, and please don't shortcut this. Okay, sine of L. Sine is opposite over the hypotenuse. Okay, now in this triangle, they are going to give you, and this one they happen to give you all 3 sides. On this one they gave you this was 8. Okay, ML is 15. And if you did the Pythagorean theorem, this hypotenuse would be 17. This one the author's nice and gave you all 3. So sine is the opposite over the hypotenuse. So when you look, if they don't give it to you, yeah, and they may give you the hypotenuse and not one of the sides. So then you'd be solving for A or B. Yeah. Okay. Okay, but on this one they give you all 3 sides, and you look at angle L. What's the opposite side? 8, and the hypotenuse is 17. Okay, so you've written it as a fraction. Now write it 4 decimals. Now on your calculator, 2 things you want to check. You want to be in decimal, or degree mode. Okay, so check your calculator up at the top. Check the mode. Make sure you are in degree mode. If you're in radian mode, this is going to mess up all your answers. So you want to make sure you're in degree mode, and I would go to, instead of floating, go to 4 decimal places and press enter. Okay. Second function quit takes you back to the home screen. Second function quit. Down in the lower right hand corner. Yep. Okay. So now when you read this, read it 8. Don't read it 8 over 17. Read it 8 divided by 17. So they're just asking you to work that and write it as 4 decimals. I get 0.4706. Okay, so there's 2 answers. They wanted it as a fraction. They wanted it as a decimal. Okay, now they want cosine. Cosine of angle L. Now you got to look at that angle. What's the side touching that angle? 15. And this would be the adjacent. Don't skip this. Write this down. Adjacent over hypotenuse. So it's 15. The hypotenuse is 17. So there's one answer. They want that as a decimal. So you take 15 divided by 17. Yep, 0.8824. Okay, and there's another answer. Okay, then they want tangent. Tangent is opposite tangent of L. Don't forget the angles. I get real picky if you leave out the angles. In trig, we'll use all Greek letters for the angle. Okay, and this is opposite over adjacent. Okay, so opposite. Now you look at angle L. Opposite angle L is 8. Adjacent angle L is 15. 17 is not adjacent angle L. It's the hypotenuse. Okay, so there's one answer. And then divide that out. 8 divided by 15. Okay, 0.533. Okay, and that's how you solve that problem. Okay. Okay, let's look at another one. Because radians are, it'd be like going, having your feet to meters. Yeah, different. It's a different unit. Yeah. So like if you did here, just as an example, I'll prove it to you. Let's say sine of 45. Okay. So I'm in degree mode right now. So if I did sine, and we're going to do stuff on the calculator here in a minute. Sine of 45. That's the right answer. Okay. If I went to the wrong mode, and did sine of 45, because now I'm actually doing sine of 45 radians. Yeah, it messes it up. Yeah. Yeah, I had people on my last trig test on the first, they had to figure like, it was 9 points on the first two columns, and they missed 18 on the first two columns because they had it in the wrong mode. Yeah, that was costly, because they didn't check their calculator first. Okay, on number 2, look at another example. Say they ask you to find sine of A, cosine of angle A, tangent of angle A. Okay, and same directions. We want it as a fraction. Okay, and we want it as a fraction and four decimal places. Okay. Now, here's what they give you. They give you a right triangle. Okay. This is our A. This is our B. This is our C. They gave us, this is 12, the side opposite, so that's actually side A. And they gave us side B was 16. Now, when you write out, I need sine of angle A is opposite over the hypotenuse. That's definition of sine. Okay? And opposite of angle A is 12. Now, here's where you're stuck. You have got to figure out the hypotenuse, so that's the Pythagorean theorem. Okay, so you go to a squared plus b squared equals c squared. Our a is 12 squared plus 16 squared equals c squared. Should be able to just punch that right in on the calculator. 12 squared plus 16 squared. I get 400. And then square root. Yep, so you take square root of both sides. Should be, what, 20? So now we know that C is 20, so that is the hypotenuse. So 12 over 20. Now, I will not take that. National Reduced Fractions Day. What goes into both of them? 2 bigger. 4. 4 goes in there 3 times. 4 goes into 25 times. Is that reduced? Yep. So there's one answer. And they want it to 4 decimal places, so take 3 divided by 5. Okay, now, do I write 0.6? No. Yeah, you need all those zeros. As they ask for 4 decimal places, give them 4 decimal places. Okay, then we want cosine of angle A. Cosine of that angle is the adjacent over the hypotenuse. Don't skip writing this down. Okay, the adjacent, so the one that's touching the angle A, the one that touches this would be 16, and the hypotenuse is 20. What goes into both of them? 4, so we'd have 4/5, and 4 divided by 5. Yep, and you want the zeros. Okay, so one answer is 4/5 for the cosine, and 0.888000. Okay, and then we need tangent of angle A is opposite. Notice where the equal sign is. You write tangent of A and then equals opposite over the adjacent. So the opposite side would be 12, adjacent side 16. 4 would go in there, 4 would go in there. I get 3/4, and that's like 0.7500. Okay. So the only difference between this one and the first problem was you had to use, and I would start this, don't forget, on right triangles you have the Pythagorean theorem to solve for any of the missing sides. Okay? Okay, now we're going to go through on the calculator, because the author's going to give you different values, and they will say use a calculator to find each value. To find each value to the nearest, on this one, nearest 10,000. Remember, it's tenths hundredths, thousandths, 10,000ths. So really they're saying 4 decimal places is what they're asking. Okay? So the very first thing you need to check is always check the mode. Like I switched mine, so I need to go back to degrees, and you got to press enter for it to register. Okay, so make sure you're in degrees. Okay, so on number 3, if they said figure the cosine of 39 degrees on the calculator, all you do is punch it in. So you'd say cosine. Notice there's we want to use the black key where it says sine, cosine, tangent. Okay, find that on your calculator, sine, cosine, tangent. So we're just going to do cosine of 39. Notice the calculator puts that parentheses in there if you need to. This one you'll actually get away with. If I did this and if I did cosine of 39, does it affect the answer on this one if I don't close it? No. Okay, so we end up with 0.7771, and that's our answer. Okay, on number 4, if they said figure the tangent of 56 degrees. Okay, so you just punch in tangent of 56. Okay, and it's 1.4826. Okay, everybody get that? Okay, on number 5, if I said find the cosine of 89 degrees. Cosine of 89, and I get 0.0175. Okay. Okay, on number 6, sine of 30 degrees. Okay. Sine of 30 degrees, 0.5000. Okay, and sine of 60 degrees. Sine of 60. Yep, 0.8660. Now think about 30, 60, 90 right triangle. 30, 60, 90. If I said this was 1, this was 2, and this was radical 3. If I said find the sine of 30, sine of 30 would be the opposite over the hypotenuse. 1 divided by 2 is, okay, if I said figure the sine of 60, sine of 60 would be the opposite, radical 3 over 2. Take radical 3, close the parentheses, divided by 2, get the 0.8660, yeah, okay. So they're actually figuring that, okay, on your calculator. On number 8, figure cosine of 45. Cosine of 45, 0.7071. So on those, all you're really doing is punching them in. You have to make sure you're in degree mode. Okay? Okay, now they will take it an extra step. Okay, let's say they ask you to solve for y to the nearest tenth. You got to follow their directions to the nearest tenth. And let's say I give you this triangle. Say this is side y. This is angle 7 degrees. That's like 7 degrees. And this hypotenuse is 60. Okay? Okay, you got to look at this picture. In terms of angle 7, and I always look at the unknown first. In terms of this angle, which side is this? Opposite or adjacent? Opposite, and this is hypotenuse. Opposite over hypotenuse. So if I do, and I always want to put the unknown up in the numerator. Saves keystrokes on your calculator. Opposite over hypotenuse. Now, go back up here, sine. So that's what I'm really figuring is the sine of angle 7 is opposite over hypotenuse. Okay, sine of 7 degrees. Opposite side is y. The hypotenuse is 60. Okay, now figure on your calculator, figure the sine of 7. Yep, and I get 0.1219 equals y divided by 60. Now, if you put the unknown up on top, it saves you keystrokes because you can always solve for that unknown read it, y divided by 60, what's the inverse of division? Multiply. So if I multiplied, now you don't have to show this. If I multiplied this by 60, and I whoops, I left off one of the decimals. 1, 2. Multiply this by 60, right? So when I do this, this is gone, right? And I have y equals. So on my calculator, all I have to do is take this times 60. Okay? And my y is 7 now. What do they want it to? Yeah, so nearest 10th, I am going to look at that. The 1, so I'm going to leave it at 7.3 equals y. Okay? So basically, I want you to write it out in words first, and then you substitute in, and then you multiply. Okay? Okay, now, up here, I gave you the angle, and I said find the value of the function. Now they're going to reverse it. Okay, draw a little separator there. Okay. Find the measure of each angle to the nearest tenth. So you look in the directions when you're working the problems. How do they want you to round it? Okay. Okay, for problem 10, sine, and they can use whatever angle, whatever letter they want. I'm going to use A, is 0.8975. What I want to know is, what's this angle? Okay? Okay, here's how you do this on the calculator. If you know the value of the function and you don't know the angle, if you look right above sine, there's inverse sine. You don't read it sine to the negative 1 power. Read it inverse sine. So do second function, because it's in yellow. So you do your second function, inverse sine. Should look like that on the calculator, inverse sine. Okay. And then 0.8975, and then press enter. Okay. Now, when you write it down, you just write down A, because we're finding the angle A. We're not finding the sine of it. So angle A is 63, and they want it to the nearest tenth, 63.8. You agree with that? Okay, so you need to write a little note out here. When you don't know the angle, you're going to use inverse sine, and you read it inverse sine. If you know the value of the function and you don't know the angle, that's when you're going to, and keystrokes, you're really doing second function sine to get there. If it's a key, I usually circle it. Okay. There's also inverse cosine, inverse tangent. Okay, so let's look at another one. If I did cosine of angle A is 0.3456. Okay, so I want inverse cosine, second function cosine of 0.3456. And the angle, if they want it to the nearest tenth, would be 69.8 if you round it. You look just at the hundredths. If it's 5 or greater, you round it up. Okay. Let's say I give you a different angle. Angle B is 0.2378. Tangent of angle B is 0.2378. I know the value of the function. I don't know the angle, so that's when I do inverse tangent and 0.2378. And I get 13.4. Now, if I wanted to check it, if I put 13.4 back in there, it's not going to be exact because I rounded it. So if I did tangent, let's say I go reverse. Tangent of 13.4, is it close to 0.2378? Yeah, it's 0.2382. It's close. You rounded it. Okay? Okay? So if you don't know the angle, you're going to do inverse sine, inverse cosine, and inverse tangent. Okay? So let's look at an example. How much time do I have? Okay. Find x to the nearest 10th. We're nearing the end. Say I give you this angle is 56 degrees. This side is x. This side is 97. What I want to know is what's the length of x? In terms of this angle, what side is this? Opposite. What side is this? Adjacent. Which trig function? Tangent. So I want tangent of 56 equals opposite over adjacent. For a while, don't shortcut that. Write it down. So tangent of 56 equals the opposite side would be x. The adjacent side would be 97. Okay? Okay? Now, tangent of 56. I know the angle, so just punch it in. Tangent of 56. Okay, and I get 1.4826 equals x. Now, instead of reading it over, x over 97, read it x divided by 97. What's the inverse of division? Multiply. So multiply by 97 on both sides, which is like, it's basically like putting this over 1 and cross multiplying. Right? So just multiply by 97. Okay, and then they want it to the nearest 10th. So I would round it to 143.8. Okay. Okay. Okay, last problem. Okay, say I give you a triangle. Say this angle's 32 degrees. This side is x. This is 15. This is angle A, angle B, and angle C. Okay, and let's say I want the cosine. Yeah. Yep. Okay, so in terms of that, let's say I didn't know this yet. In terms of the 32, this would be the adjacent side, and this would be the hypotenuse. So adjacent over hypotenuse. You always want to put the unknown up on top. Okay, so it's cosine. Okay, the cosine of angle A is the adjacent side over the hypotenuse. So cosine of 32, and I could write 32 up there instead of the A, is the adjacent is x over 15. Okay, so punch in the cosine of 32 and write down 0.848. And I do want to see this work. I don't want just the answer. Showing me the answer is not going to help you. Okay? You got to show the work. Read that, x divided by 15, do the inverse, multiply by 15. And x is 12. They want it to the nearest 10th to be 12.7. Okay? Okay. We got maybe 2 minutes left. What's up? Not